Computer versus I. I am Krish Patel, a bachelor's of neuroscience student who will be kind of explaining this experiment here. So first, the purpose of this experiment. So we have an overarching purpose, which would be testing the application of Newton's second law. What that means is kind of the acceleration theory, and we'll be using a tennis ball here. For our purposes, as the examination subject, in order to test the position and velocity versus time. And the overall goal of this specific experiment, for my purposes, is to compare the differences between the observed model, which would be taken via live video and observed through tracker, and a computationally developed model using GlowScript code, which will go into more derived from that observational video. Mechanism of experimentation here. Like I said, we'll be using a tracker software given to us in which a recorded MOV file will be examined, and it will contain the video with the tennis ball examination subject. Tracker will then be our means of analysis in order to develop use coordinates and develop a full table to develop a graph based on the observed model and the observed data, which will be collected via the video in the tennis ball subject. Now, GlowScript program through use of our physics equations of vectors and initial positions. It was then used for comparison to develop a computational model, which will kind of serve as a theoretical model. And the goal of this experiment, for my purposes, is to kind of compare the two, the observed model versus the computationally developed model. Here's the live video obtained for our purposes right here. And the way that this was set up is this whiteboard will be kind of our frame of reference to be analyzed within Tracker. So the tennis ball was actually started from over here and ended over here, and this whiteboard area is easy for us to put in a Tracker, analyze it, and it also is the point where the tennis ball is not really speeding up or slowing down. So it kind of gives us the most theoretical, the perfect data set versus it, kind of speeding up here, slowing down here, obviously due to drag. So we wanted to get that best steady pace, which will be the whiteboard section right there for our purposes in Tracker. Now, the video was taken via an iPhone and uploaded into Tracker's MOV file, and following the given steps, the derived information is here in front of you. So we have a plot on the left side of mass A, which serves as the tennis ball subject, shown through the 0.600 seconds of examination time, which would be from that front point of the whiteboard to the end of the whiteboard. We can see between the two, the table and the graph, we can see the different positions at certain times of where the experimental data, where the tennis ball was at a certain given point in time. Now, this was then taken to develop the initial position based on the position at time 0 and the total amount of time, and the difference between time at 0.033 seconds and 0, and therefore the x value 2.842 e to the negative 2 and 3.784 e to the negative 3. Now that was plugged into our GlowScript code, which will be gone through at the end to develop the GlowScript code, which is the theoretical graph that we can see in front of you. So it's using the same 0.600 seconds frame of reference, and this is using the initial vector, initial position, or initial velocity, initial position. We can develop here a theoretical graph at which time the tennis ball should be at which position in meters here. And then GlowScript has this function to where we can observe this through the use of the code in the graph, to where this is the theoretical motion of our tennis ball. And you can see that it moves in that small, linear, perfect fashion, just as the tennis ball did in the original video. Conclusion. The goal of the experiment was to see if the data analyzed from the video could be used to demonstrate a computational model similar to the observed model. And therefore, as discussed, the data community that it can be seen that the observed model was able to replicate a computational model that is accurate and is identical to the initial observed video using the tennis ball. The attached code we right here linked as a YouTube video, and right here, as you can see, is the code for Python, which contains all of our position vectors and velocity vectors, which will then be used when you run the program to create that graph and video that was shown that is identical to the observed model.